train wheels move along the rails guided only by the pound coin sized area of wheel that sits on the railhead. The wheel rim, or flange, doesn't normally touch the rail. Flanges are only a last resort to prevent the wheels becoming derailed. A switch can guide a wheel in one of two directions. A crossing creates a gap in the rail for the flange to pass through. This is a switch. Also known as a point, it's the moving part of the switch and crossing layout, and is made up of two long blades which can move across to guide the train one way or another. This is the switch rail, and this is called the toe. This is called the stock rail. It's a non-moving part of the switch. The two switch blades are fixed to each other by a stretcher bar to ensure that when one is against its stock rail, the other is fully clear and will provide room for the wheel flange to pass through cleanly. This is a crossing. It's the non-moving part of the switch and crossing layout that allows a train to pass in either direction once the switch has been set. This is the nose of the crossing. Either side of the crossing area, wing and check rails are provided to assist the guidance of the wheel sets through the crossing. Crossings can be either fabricated, made up of two machined rails joined together, or they can be cast as a single unit. Modern crossings are now cast from manganese steel, which is an advanced alloy that gets harder with use. This is an important property, as the nose of the crossing can take high impact loads as train wheels pass through.
This is how it works. In normal mode, the left-hand wheel rolls along the switch rail, and there's flangeway clearance for the right wheel to continue along the stock rail. The inside surface of the right flange is kept on course by the check rail. This restrains the wheel set and ensures it is directed along the correct route. Meanwhile, the left wheel transfers contact between the different parts of the crossing. That's where there's a high impact load. In the reverse, the right wheel rolls over the switch rail and follows its geometry. The inside surface of the left flange is guided by the check, forcing it to follow the stock rail on the new route. And the right-hand wheel makes a crossing, again impacting a load on the crossing nose.
There are many different types of switch and crossing on the network. They include turnouts, diamonds, crossovers, and slit diamonds.